Good afternoon, everybody, and welcome to our joint webinar today. This one is with MasterSeries. I'm joined today by Andras Herbe from MasterSeries. My name is Ralph Pullinger, and I am from IDEA StatiCa UK. And today we'll be going through the link between MasterSeries and IDEA StatiCa. Today's agenda looks like this. First of all, just to warn you all, this webinar is being recorded and it will be made available after the presentation. If you wish to ask questions, you can do so using the panel in the GoToWebinar panel. And if there are any problems, please let us know in the chat and someone will be able to help you. Today we'll be going through some brief introductions. There'll be a couple of polls as well before we get into talking about MasterSeries, IDEA StatiCa, what I like to call connected connection design, which will demonstrate visually and also in a workflow, and there'll be plenty of time at the end for questions. So a little bit about myself. I'm a product engineer with IDEA StatiCa UK. I've been with IDEA StatiCa now for nearly 5 years. I'm a structural engineer by trade, with over 40 years of experience in the form of consultancy and software. From a drawing perspective, I started off on the board and then migrated through CAD and then on into BIM. Specialize in analysis, integration workflows, and computational design. My favorite question to ask, and those of you that know me will all understand this, is why? And that's one of the hardest, easy question to ask and a very hard one to answer most of the time. So over to Andras.
Thank you, Ralph, and welcome everyone. It's great to be here, and a big thank you to IDEA StatiCa UK for inviting us to be part of this webinar. My name is Andras Herbe, and I'm the sales manager at MasterSeries. I graduated as a structural engineer from the Technical University of Budapest. I spent the first years of my career as a designer in one of Hungary's largest design and build firms before moving into the software side of the industry. For almost 15 years now, I've specialized in structural analysis and design software, supporting engineers in streamlining their workflows and getting more from their design tools. Okay, before we move on, we have a quick poll just to get a sense of who is attending today.
So I've just launched the poll. And yeah, we'd just like to get an idea of our audience, basically. And I'll leave this open for a little while. Just for a few more seconds. And then I will close. And I'm going to share those results with everybody.
Okay.
So hopefully you can see that what we have, who we have online. We have a good mix. Lots of people who are using both. Roughly about half the audience, just over a third of the audience are using MasterSeries alone, and then about a is that about a ninth of the audience are using IDEA StatiCa, and just under 10% aren't using either at the moment. So a good spread. Thank you for that. And I will let Andras continue explaining about what MasterSeries have to offer.
Right. Yes, MasterSeries is a modular suite that includes a wide range of structure analysis and design tools, from focused standalone modules such as connection design or masonry design, right through to fully integrated 3D frame analysis and design solutions. Here you can see the full MasterSeries product range. On the left is the building design suite, our complete frame analysis and design solution. The BDS is ideal for multi-user environments, as its modular structure means that analysis and design add-ons can be shared across the office using floating licenses. This allows engineering teams to access only the tool they need when they need them, without purchasing the entire solution multiple times. In the middle, we have PowerPad, our light suite for smaller and medium-sized projects. It includes a 200-member version of the building design suite, Lite, along with a light version of all standalone modules. On the right are our standalone modules, including masonry, retaining wall connection, pie caps, composite beams, and our steel and concrete beam designers. The full version of standalone modules can be purchased separately, or they can be added to any design suite, including both PowerPad and the building design suite. And lastly, all MasterSeries licenses are floating licenses, meaning they are not tied to a specific user or PC. This allows teams to work flexibly, share tools efficiently, and maximize values across the office. Thanks, Rob.
Thank you. So those of you that don't know about ourselves, IDEA StatiCa, we have over 8,000 desktop licenses throughout the world. We are linked to over 20 finite element analysis applications like MasterSeries and CAD or BIM solutions. We have a network of over 40 resellers globally and over 120 employees within the company. What sets us aside from similar providers is the fact that our software is validated by universities. We have an extensive research and development facility, which is distributed around the world, and we use several well-known universities on different continents, some doing concrete, some doing steel verifications. We're known for our, I would say, for our steel side of things more than anything, but our concrete portfolio was the first to exist when we started the company. We specialize in connection design, any geometry, any load configuration, but also steel member optimization. On the concrete side, we do 2D plane and 2D vertical members, as well as the relative new kid on the block, which was 3D concrete design and code checks, which might take a while to get your head around. It certainly did me, but it's a very exciting development in the world of 3D concrete, but also an integrated workflow, which you'll see in the next few minutes. So the main reason we're here today is to celebrate our partnership with MasterSeries, and we're excited to bring you a new chapter in both our companies, really, and to celebrate that, we are offering new users of both pieces of software 20% discount. If you are an existing user of one or the other, then we'll be pleased to offer you 10% off the one that you are missing. So either way, you get to benefit from extending your portfolio. So those of you that only have MasterSeries but would like IDEA, or vice versa, we will offer you 10%. And those of you that don't have either, the 8% of you from the previous poll, you'll be pleased to know that you're going to get an extra 10%. So that's 20% off both pieces of software, or 10% off what I would call the missing one. So why do I call this connected connection design? Well, the simple reason is that collaboration is the key, and collaboration will take many forms, but for me it's when we don't duplicate the information, we build on it over the periods of over the touch points of the design of the project. So when we talk about BIM, the key word is information, and hopefully we all recognize that it is very dangerous to duplicate that information, or even to attempt to duplicate that information. And it's also very wasteful and time consuming. And we definitely know from research that when we talk about connections, it takes 80% to do 80% of your time to do 20% of the connections. But, or let me put that another way around, sorry. It takes 20% of your time to do 80% of the connections, but it takes a lot longer to do the remaining connections. And the reason for that is we see data drop off at key handover stages. And what we really should be doing is trying to streamline that workflow wherever possible to avoid that duplication, to avoid data drop off. And to highlight that, what we're going to do is we're going to take you through a workflow. That workflow is going to involve taking a global analysis model. We're going to push it through into our collaboration hub, which is called Checkbot. From there, we can send it out to member or connection. In today's webinar, we're going to focus on connection, and we can then generate additional files to supplement the downstream use of that information with regards to detailing or highlighting what the connection looks like to clients, customers, or architects, etc. That means we've got no data loss. The integrity of the results is maintained. We have an efficient approach to design and code checking, and it's integrated, which means we have multiple people talking to each other at multiple times along the life of the project. This is what we're going to be talking about today. We're going to be talking about MasterSeries, Checkbot, and connection. And just as a side note, this link is relatively new, and already it is showing signs of being a very popular link, being used extensively throughout the UK, where it is currently sitting at number 5 in the league charts. And if we were to include Ireland in that, then it's actually sitting at number 6 when we talk about UK and Ireland. So it's only been in existence a short time, but it's already being used extensively throughout the UK and Ireland. And I'm going to ask Andras to talk about the project that we're going to be showcasing today and using in our workflow.
Okay, to demonstrate our joint stair design workflow today, we will be using a prestigious real-world project from one of our clients, the new 340 million Belfast Grand Central Station, structurally designed by Doran Consulting, and the project features expansive open plan hall spaces with a combination of steel and concrete structures. The station accommodates high pedestrian traffic, bus and rail platforms, and commercial areas, making it a complex and highly visible public building. Its design focused on durability, safety, and long-term serviceability, which makes it an excellent example for today's demonstration.
It certainly does. It's a beautiful project.
Okay, let's begin by looking at the structural model of Belfast Grand Central Station. This is a large building designed by Doran Consulting using MasterSeries building design suite. The designer used Eurocode, though British and South African codes are also available. The layout resembles a big arrow, and the building provides huge open spaces for buses and trains. Today, we won't build a new model from scratch. Instead, I will walk through the completed model and show how it together with the analysis results fits into IDEA StatiCa for connection design and verification. The model contains mostly steel members. The roof features huge trusses spanning 10 to 25 meters with an exceptional truss spanning 60 meters. Between the trusses, there are cellular steel beams that help distribute loads and provide stiffness to the roof structure. Some trusses are supported by 10-meter high steel columns, while others sit on the top of 2 massive concrete walls, which were modeled using finite element surfaces. The building also has small composite levels at some areas. The outer faces are covered with a glass glazing system. The model includes the main structural elements of this glazing. The designer supplied gravity loads, dead, live, and other loads as full area loads using one-way spanning area load panels. These panels distribute the load to the supporting members at the edges automatically. And if we turn on the area load visualizations, the panels are colored by intensity, and the accompanying color legend shows the loads on each panel. For wind loads, the designer used the inbuilt wind analysis module to generate wind pressures in every 45-degree direction, including internal pressure and suction. Turning on the wind visualizations allows us to review the applied wind panels and see the generated wind coefficients and pressure values for each zone in each direction. The only input required is the site location, which can be selected via Google Maps, though other options such as postcode or coordinates are also available. An interesting fact is that Google Maps already shows the hub that has been opened. And once the site is selected, module automatically creates the zoning and calculates the wind pressure on the structure. If we switch to color by section under the 3D option, we can review the allocated section sizes and material grades. Using frame views, we can concentrate on a level or grid line. All the relevant load cases and combinations, including horizontal notional forces as per wind, have been generated directly in MasterSeries. First, I will switch to one of the frame views so we can focus on a single frame. From here, we can review the full range of analysis results, deflected shape of the structure. We can turn on in-span and nodal deflection values, bending moment diagrams in both the major and minor axes, shear force and axial force diagrams. If you want to quickly review the maximum and the minimum values across all combinations, we can simply switch to one of the envelope results. And of course, for the shear walls and FE surfaces, we can review all shell element results as well, deflections, membrane forces, bending moment, and the various stress components. With the frame analyzed, we can move on to the design stage. In the MasterSeries, the design tools are modular. This time, I will focus specifically on the steel member design. We can design members individually, or we can create design groups so that all elements in the group are designed together for the worst case scenario. MasterSeries automatically identifies the governing ULS and SLS load combinations and runs the design checks for those combinations. On the left-hand side, we can review the detailed calculation, including local capacity, buckling resistance, and serviceability cases. On the design tab below, we can adjust any of the design parameters, such as buckling lengths, design factors, or deflection limit. If needed, the auto design tool can quickly find the lightest or the shallowest section that still satisfies all requirements. Once the design is complete, we can run scan for failures to check whether any briefs are failing, and we can display utilization ratios on all members, highlight only the critical member in each group, or even isolate just the failing members if we want to focus on issues. Under the BIM Exchange main menu, we can find the IDEA StatiCa export function. Using the link, we can export either the whole or only a selected portion of the model, including all analysis results, directly into the IDEA StatiCa chatbot. On the link tab, we can select the program directory of the IDEA StatiCa and the project which will be created during the export. On the load case tab, we can choose which load cases to export. There is also an auto select critical load cases option. On the member tab, we can choose whether to export physical members or analytical members. Physical members keeps each member as a single piece without internal nodes. Analytical members automatically splits members at every connecting member, creating internal nodes. On the Export tab, we can select the purpose of the export. If we choose connections, only member and forces are exported, which is sufficient for connection design. However, if you want to use IDEA StatiCa's member design tool, we must export intermediate forces along the member as well. Once everything is set, we simply select the members we want to export and click Start Checkbot. And remember, it's not necessary to export the full structure. Exporting only the relevant portion is perfectly fine. And with that, I would like to hand the presentation over to Ralph, who will take you through the next stage.
Thanks, Andras. Well, the first part then is to import the relevant nodes into Checkbot, which thankfully we actually sped up for you today. This is a big project, lots of connections, and you'll be thankful to know that we've provided tools in Checkbot to help you organize those connections into like connection groups. So the first thing that you see highlighted down there on the right hand side of your workspace are just one of the many groups that has been created. And just like Andras has mentioned with failing members, the use of these design groups allows you to focus on one parent connection, which, let's say for argument's sake, is at the top of the tree, and then all of the children under that parent connection inherit the same details, the same operations, the same connection type as the parent. So this means you only need to focus on one main connection, and then you can let the children inherit the design and be checked. Probably some of those children will fail, but you'll know which ones fail, which means that you can then just allocate time to check the ones that are failing as opposed to checking all of them. And again, the aim is to maximize the efficiency of your time as an engineer going through all of these connection designs. So I'm actually going to focus in on one of the stub columns that bears onto the shear wall. And as you can see from this model, it's actually made up of smaller analytical components, but together they make up the one column. So yes, we're focusing on the base plate in this instance, but we can actually merge the components of this member together so that it forms one member with regards to the Checkbot model. So this merging facility is quite useful because it allows us to assimilate the members together and eliminate connections where there are no connections themselves. So we can see from when we highlight this node that it forms part of another group, but this is a specific group that we're looking at, so we can remove it from that group, create another group from it, and call it something meaningful, like stub column, for instance. Now, throughout this whole exercise, what we are doing is we've taken the geometry from MasterSeries and also all of the relevant load case combinations. And then what we can do is open up connection directly from Checkbot. This will import the relevant geometry, i.e. the stub column, and it will also import all of the relevant worst case load effects. So I don't know if you remember, but in the MasterSeries model, there was several dozen combinations. And through clever algorithms, we've actually been able to reduce that down to 3. And that means that we can further reduce our computation time when we check the design itself. So very useful tools on board are the measuring tool. So not only do we know that it's a UC 305 section, but we also know the distance between the flanges and the webs, etc. So when we come to add a base plate, that's added as a single operation. All of our operations, or some of our operations, take the form of several operations nested together. So a base plate is essentially a plate, a cut, some welds, and some holding down bolts. So we just add those using one single operation, and then we can control the positions of the bolts, the holding down bolts, the with regards to X and Y setting out locations. And we can also change the overall size of the base plate. Importantly for this exercise is we want to try and mimic the width of the concrete wall that this column is actually bearing on. And we can do that using a series of syntax entries into the offsets of the foundation block. And once we have the offsets coded in, then the supporting concrete block will change shape and replicate the wall that is under. We can increase the size of the plate, we can change the concrete grade, and we can change the weld leg sizes. The measuring tool also allows us to check the width of section that we want to analyze and the height or depth of section. This means that when we put our offsets in, it will mimic the wall that we want to work with. So we just need to know the offsets from the edge of the plate to the edge of the concrete that we are considering. And I'm just figuring out what those offsets are at the moment so that it makes perfect sense. I'm spending time here because I want to get this right, because we are going to be reusing this information further on down the way. So this stud column bared on a pocket in a wall, and yeah, I can model the wall either side and treat it as a pocket as well if I wanted to, but I'm just going to treat it as a glorified foundation block essentially. But I'm going to be doing some extended calculations. So here we've got a post-installed threaded rod, and we've done the initial anchor checks, and we've got passes. When we look at that in more detail, we can see what the stress distribution is, the contact stresses against the concrete, which are really quite low, and the bolt forces. We can also look at the deformed shape if we want to, as well as we have the detailed checks associated with the anchors, welds, and the plates. So if we were to look at an anchor check, for instance, using the print preview, you can see that we are utilizing the forces obtained from the analysis in IDEA StatiCa as a check against the allowable design values taken from code. And it's reporting us a pass or fail based on those interaction diagrams. So one of the newest features of IDEA StatiCa is the ability to integrate this design with our 3D detail application. It's a relatively new extension to the workflow, but this allows this design to be passed on in its entirety page, which would be detailed concrete checks. The only thing that is missing at the moment is the reinforcement, and also to further restrain the wall with additional supports based on the surrounding wall block around this extract. So we can just, rather than model a lot of wall, we can add essentially continuity to the bottom face and the side faces, and importantly, make them the right type of continuity as well. So you can see there as well that we've got the three load cases that were in use in connection. You can also see that we've got the same size base plate, and the anchors have come through from exactly the same anchor types and lengths, etc., as they were in connection. So we're not having to duplicate anything here at all. There'll be a side at the end of this little extract as well. So the base plate doesn't have to sit directly on the wall. It can also sit using a mortar joint. The one thing that was missing though with the transfer was the information regarding the rebar. So we have to build that in ourselves now as we go. And we do that by assigning a diameter, and then we tell the application what that reinforcement looks like by one of several methods. So we're going to use edges as our definition once we've defined the surface. So our edges to get a U-bar would need to be 3 in quantity, in this case 2, 3, and 4, and we end up with a U-bar. We do have different definition techniques as well, but using the edges of a surface is by far the easiest way to input the data. And again, we can tell the application that we've got continuity past the support with the anchorage type. So we need to tell the reinforcement where it is within the concrete block, and we do that by amending the cover and the surface cover. To get a number of rebars or reinforcement along the length of the wall pocket, we just give it a number and spacing. And visually you can see when we look at elevation where these reinforcement pieces sit in relation to the holding down bolts. The reinforcement where either it's been designed to go, or in instances where we need to do a site validation where the reinforcement has actually been placed on site. Just like many other operations in IDEA StatiCa, we can copy the rebar and amend its surface and edge definitions, which means then to define the distribution steel, we just need to rethink our covers. Basically, that's the cover to the top and the side cover, which should take into account the cover to the U-bars. And again, it's very visual. So when we look at the U-bar, the distribution bars against the U-bars, we get a very good indication as to how it's or where it's sitting within the cage itself. So when we flip to the end view, we can see that we need to tidy up our covers. So the shape position gives it a essentially, let's say, a start elevation, and the user cover would give it the side cover. So as we flip between the two different reinforcements, we'll get a better idea of where these bars sit within the cage itself, and we can adjust the user value to take into account starting at the bottom of the radius. In reality, it will be fixed slightly differently, but this is where we're going to detail it. In this particular instance, we can just copy this reinforcement definition to the other, and we've got an instant copy in the right place of the same distribution reinforcement. So the next stage in our process is to do the calculations to thoroughly check the anchorage and the reinforcement within this zone. This is a relatively quick exercise based on the information within the model itself. Obviously, the more pieces of reinforcement, the bigger the concrete block, the more load cases that you have, all factor into the length of time that the analysis actually takes. And for the purpose of this demonstration, I'm also speeding this up so that we can see the results much faster. So what we're looking at is a brief summary, just like we have in connection, as to the limiting values for the checks for the concrete, the reinforcement, the anchors, and the anchorage. We get to look, or we can look at the stress flow within the concrete block. As you can see there, it's very concentrated around the anchors. But we can also look at the strength with regards to strains and stresses within the concrete block, and even deflections. We will also, or we are also able to look at the anchorage results, so that we can see where the most onerous bar position is within the cage. So we do get a full listing of anchorage results per load case, and we also get a visual check as to where the worst one is, which is in the bend of that middle U-bar at 97% utilization. So I mentioned deflections previous, and here we can see we have a deflected shape where the top is settling slightly and the sides are bulging again ever so slightly. Now, it wouldn't be the same if we couldn't generate a report. So a report allows us to communicate the design to other people for checking or for further validation. The report can be output to straight to printer, or it can indeed be output to document, PDF, or in some cases DXF as well. So contained within the report are all of the necessary inputs and outputs to validate the concrete and its reinforcement placement. And those of you that are already thinking, I can do 3D concrete for other situations, not just stub columns, you would be right. In the model itself, there are instances where we have horizontal beams joining onto the shear wall, and there is nothing stopping us now doing a cast-in plate design for those steel beam ends and bearing into the concrete core walls. That validation or that release will be with us very, very soon, which is why I'm not actually showing it today, unfortunately. That concludes our workflow visualization. And to close out the, or start to close out the webinar, I just have another quick poll for you all. So, were you actually aware that we had a link from MasterSeries to IDEA? And this might seem a daft question given that what we've just done, but it's important for us to understand, are we sending you, our joint customers, the right messages? And given the split, I'm going to stop this now and share the results. Given the split, Andrash, I would say we might need to do a little bit more.
Yeah.
Being a 50-50 split. So yeah, not in some respects, I think you can probably say that's good because we're hitting the mark with 50% of the market, but also bad as well because 50% of the market are missing out on something. So yeah, something for us to work harder at. And now we've certainly got 10 minutes for questions and answers. I'll just hide that poll. And let's have a look at the questions that we have coming in.
Okay, hello from me as well. So we have a few questions coming in. Obviously, there are a few questions regarding pricing and packages, which would be happy to answer by an email or through the phone. I've already answered a few questions on that already, but we can follow up after that. I'm going to focus a little bit on some technical questions that have come in. And the first one is for Andras, and it is related to the capability of using the link.
Okay.
The question is, as an existing MasterSeries user without FEA capabilities, would I need to add that MS package before being able to add use IDEA StatiCa?
Yes.
Link?
Yeah. You only need is the BIM link module. So if you want to use the link between MasterSeries and the IDEA StatiCa, then you need the BIM link on the license. So it's the link doesn't require the FE capabilities. You only need just the BIM package.
Okay, perfect. Another question says why bolt forces after activation do not appear in connection?
Yeah. So very keen-eyed, yes, absolutely. But there was quite a large axial downward force on the end of the column. So essentially, the column, there's no tension within the bolts themselves. So hence no bolt force.
Yeah, I think actually there was a follow-up on that because there was compression only. So that's basically answers the question. Okay. Another question, base plate design, is the software designing for biaxial bending as opposed to primary axis, and meaning ignoring minor axis as per MasterSeries?
So I'm not totally au fait with the MasterSeries approach, but with IDEA StatiCa, excuse me, we are looking at all of the load effects on the system, which means that we can offer a comprehensive approach. And again, it's based on a combination by combination approach. So if there was a major axis and a minor axis bending, as well as axial and shears, all of those load effects would be taken into account when we do our connection design check.
Okay, another question. Your option include a post-fixed anchor. That doesn't seem to be available in my IDEA StatiCa. Is this a new feature?
Yes, it is a relatively new feature. The version that I used to record the workflow, probably you don't have access to yet, but it was stable enough for me to do that. So it brings me on to another point about making certain that your version of IDEA StatiCa is up to date. And then it's another good reason to keep up the maintenance with your IDEA StatiCa solutions, because without that maintenance, you do not get access to the latest versions. Yes, you'll get the current patches within the build, but if we went for the next major version, you would be missing out on an awful lot of functionality.
Okay, another question regarding the link. What happens? I'm not sure if maybe Andras can answer that, or both. What happens if at a later stage modifications to the steelwork model are required after the connections have already been designed? As far as I know, MasterSeries automatically renumbers nodes when the geometry is changed or additional members are introduced. Will the IDEA StatiCa connections still remain linked correctly?
Yes, the good news is that the connection or the link between MasterSeries and IDEA StatiCa remains active in the background. So this means that any stage we can return to the export function and we can update the results and push the revised data straight back into checkboard. Yes, the user is correct that MasterSeries automatically renumbers all the nodes and members. However, I'm not familiar with the background of this link, but we usually use a static IDs for beam links, so it will so the connection remains correct between the two programs.
I can vouch for that as well, because I reran the analysis and updated my model and the chatbot model, and that updated using the new loads, and the members were fine. They inherited the new loads themselves. So as Andras said, it uses unique IDs rather than node or member numbers, and it just does it. So updating the information is as simple as reconnecting and resyncing the models together.
Okay. More questions are coming. This is really good. I think it's
Good.
people are really interested in that. Yeah. Next question. Let's go. Let's try to answer as many as possible. Is it possible to design wind turbine bases in IDEA? I think this is possible. Maybe Ralph, you can.
In theory, yes, but I wouldn't. It's a use case that we haven't verified, and for obvious reasons, we tend to allow or suggest various use cases once we are happy with the approach, which normally involves validation verification exercises. If we're talking about the huge masts that we see in the countryside, in valleys and on hilltops, then I would say it's slightly outside of our scope at the moment.
Yeah. I think I remember at some point I saw a project from a customer, something similar a while ago, but yeah, I would, as Ralph said, it's not something that we have really verified based on our procedures, but it could be used, I think. Obviously with engineering judgment as well. Yes. Another question, when looking at steel-to-steel connections, does the transferred model show everything on center line, or will it show, say, for example, offset beams to columns? I'm not sure who wants to answer this one.
I can take that one for now, and then Andras maybe can chip in. The members themselves would come in on center line by default, if no offsets are given within the analysis model. But in Checkbot now, we have the ability to line up multiple members on a given level with a plate, say, for instance. So we can align multiple members very quickly so that they have consistent top of steels. We can also further adjust those by using offsets within Checkbot, so that when the actual connection node comes into IDEA StatiCa connection, the members are actually in the right place. Yes, they'll have the same load effects on, which might introduce some slight discrepancies, but still within the realms of acceptability. Anything to add with regards to offsets, Andras?
At the moment, we transferred the analytical model into IDEA StatiCa, so the offsets you applied on the MasterSeries model won't be exported into IDEA StatiCa at the moment. Yeah. We have to check the possibilities if we can solve this issue, but at the moment we are transferring the analytical model with no offsets into IDEA StatiCa. So if you have offsets, then you have to apply these directly on the IDEA StatiCa model.
I think we're certainly still in. I mean, this link is still in its infancy. We both of us, that's the royal us, respond to customer input. So if you would like those offsets to be taken into account, then get in touch and let us know why you do and what benefit it would be for you, and then we can look at integrating that into further development.
Okay, more questions are coming. I'm conscious of time. I mean, I think we're basically just over an hour. I mean, happy to stay for another 5-10 minutes if people wants to stay for the rest of the questions. But I would say, like, let's answer 2 more questions.
Yeah.
Questions. We can wrap it up.
Yeah.
I will jump in one question that I think it's actually really important for everybody to understand, and I think this is for Andras. MasterSeries have a steelwork connection tool. Will this be supported going forward, or will this be dropped in favor of the IDEA StatiCa connection too?
Yes, the master key connection design will be remaining a strong or solid part of our offering. So we, yes, we are still developing it, and our connection design program is the best, as we can see, is the best solution for standard connection. However, for enhanced or high level connection design, we are partnering with IDEA StatiCa, and that's the reason why we developed this link to provide an option to connect the 2 software. So my answer is that yes, our connection design software will remain part of our product range, and we are still developing it and continuously adding more functionalities to it.
That's one of the main reasons why I talked about the 80-20 rule within the presentation. So recognizing that you can do 80% of the connections in 20% of your time, possibly using the connection tool within MasterSeries. But what we were both finding with customers is that they struggle to do the remaining 20%, and that costs dearly, which is why this partnership has come about between IDEA StatiCa and MasterSeries, so that you, the customer, can get the benefit of both pieces of software. And it's about cooperation, partnerships, and not being protectionist, recognizing that we both have strengths and we play to those strengths.
Okay, and just one last question. Would the link work with a full FE model, i.e. for a plated structure?
At the moment, we export 1D element, beams, columns, bracing. So at the moment, the plated structures or FE surfaces are not part of the exported model. Hopefully, in the future, we'll have some facilities to do this.
So those questions that we haven't been able to answer today, we will answer, and we will get back to you, because we know who's asked the questions and we know where to send the answers to. So apologies if we haven't got round to answering them today. There's been an awful lot of questions, which means that there's an awful lot of interest in this approach. So yes, we will get back to you, and we will get back to you just as quickly as we can. So if you would like to know more about IDEA StatiCa or MasterSeries, we have 2 QR codes on your screen now. They do work because we've tested them, and this will actually very, very quickly allow you to ask for more information from us, and we will get back to you even faster. I'll leave that up for a little while. And it only goes for me to say thank you very much for being here today. We really do appreciate your time, and hopefully you've had a good webinar with us today. And I will say see you at the next webinar. Andras?
Yes, thank you very much. Thank you all.
And thank you, Theo, for being our moderator.
No problem at all. Thank you all for joining.
Thank
See
you.
you next time.
Thank you. Thank you. Bye.